All right, so for this power and going to be a power factor correction because it's going to say before and after correction, right? So what are we correcting it to? We're bringing the power factor, right? That's FP on the equation sheet to unity, which means the goal is to bring it to 1, right? That's the goal of power factor correction, is to make FP 1. If FP is equal to 1, and that is P over S, then another way of saying that would be that we want P to equal S, right? And so initially we had a power, we're gonna have a power triangle, and I can tell it's already inductive because here's an inductor, 30J. There's no capacitor, so we're gonna have an inductive circuit. And what we're gonna do is we're gonna add a Q. We need a negative Q that's going to essentially add a vector here, so that what we're left with is a line where we no longer have a triangle, but we have P and S are the same length, right? The length of S on our triangle is the same as the length of P. Another way to say that, if power factor is cosine, then we need our cosine to equal 1, which means the theta will equal 0. And that makes sense. We went from a triangle to just a line, and so there is no angle. The angle is 0. It's flat. So the first step that we would do for this one, if I need to find it, the goal is to get to my Q, right? So how do I get to the Q? I'm gonna need, the way for me to do this is I'm gonna get to S equals V I complex conjugate. And the reason I'm gonna do that is because if I can get S as a vector, then I will have P plus or minus JQ, and that will give me the Q I need, right? So I have my V, so what I'm gonna have to solve for is I, right? And so my 3 steps to get to the Q that I need is I'm gonna do V equals IZ, S equals VI, and then you just put it into the rectangular format. So if I'm looking at the totals here, these are kind of my steps on the left, and I'm gonna actually solve it on the right. Okay, so my Z total is going to be 60 is paralleled with 20 plus J 30. Is everyone okay with that as my Z total? That's a relatively easy Z total, but there are others in the course where it's just this idea of writing parallel. Any questions on that before I keep going? Nope. Okay, so my Z total, let me grab that number. Make sure I get it to you right. Actually, real quick, I'm gonna write, if I was writing this in my calculator, the way I would write it is I would do the 1 over fraction, 1 over 60 plus 1 over 20 plus J30. And remember on the calculator, it's the J is the imaginary I. And so that Z total, 25.3 ohms, angle 35.8. So now that I plug that in, V equals IZ, I equals V over Z, V being 120 angle 0, Z being 25.3 angle 35.8, and my I is 4.74 angle negative 35.8 degrees. Note that's also, is that part B? That's not the load current, but that is the source current. So it's not the load current, it is the source current, I source or I total, right, initially, prior to correction. And my next step, S equals VI complex conjugate, S equals 120 angle 0, I is 4.74 angle complex conjugate now, means it's a positive 35.8. And my S, do I have S solved here? No, I need to get my calculator. But here is plus J, and this solution, it just has this part, 332 VAR. Since going on my trip, I think my calculator's in my backpack. Does anybody want me to provide those answers, or are y'all okay to plug that in? Okay, sounds like y'all can plug those in. So what I'm doing though is this is my Q, right? So this is the Q that I need to cancel. That negative Q. So that means I had a positive 332 VAR. So now I'm going to do a Q of 332, and I'm just writing VAR capacitive to let me know I'm solving for it capacitive. If I was plugging it in to like with a negative J, it would be negative J 332, but I need 332 VAR capacitive. So I'm setting up the equation Q equals V absolute value squared over X, and I rearrange X equals V squared over Q. V is 120. I don't need its angle. It's just the absolute value, which means the magnitude, so 120. That Q is 332. And that comes out to X equals 43.3 ohms. And I have X equals 1 over 2 pi FC. Rearrange that for C. And I have 1 over 2 pi Fx. 1 over 2 pi, 60. X, 43.3. And my final C in farads is 61.1 microfarads. So the first part, determine the total load current before and after correction. Well, before correction, we found that as part of how we solved for it. 4.74 amps, angle negative 35.8. Part B, well, I have now a new Z total because essentially I'm plugging in parallel with the total load, a capacitor of 61.1 microfarads. All right, so I have an added element of a capacitor of 61.1 microfarads. Its reactance was 43.3. So if I had a new Z total, I do 1 over 60 still there, 1 over 20 plus J30 is still there, but now also in parallel, I have that 61.1 microfarad capacitor. Well, it turns out its reactance is 43.3, so I put negative J, 43.3, and I get a new Z total, which is 31.2 angle 0. And that makes sense that it have an angle 0, because if it has an angle 0, that means it's neither capacitive nor inductive, it's purely resistive. And that makes sense because we needed a purely resistive circuit if we wanted our power factor at unity. This angle would be 0 because we said at unity, this theta is 0. Well, that theta is the theta of the power triangle, but it's also the theta Z of the total circuit. So 31.2, so then I use V equals IZ, rearrange for I equals V over Z. And so my new I, still the same voltage source, but now it's 31.2 angle 0. And my I new is 3.8, 85, I think, 85 amps, angle 0. And that also makes sense when I just look at that 3.85 is less than 4.74. And that's the goal of power factor correction, or not the the goal is to get it to unity, but the reason we want it at unity is we want to minimize that current so that if we have losses in the line, we're not just wasting energy transmitting, having heat losses up in the wires, that the current efficiently is made, and we can have a smaller generator because we're generating a smaller current. Multiple reasons, but that's the why of power factor correction.